Hi, this video is about normalizing a database from normal forms 1, 2, 3, and 4. For the example, I mocked up an imaginary company that sells video game consoles. Uh, some of their products are Xbox One from Microsoft, PlayStation 4 from Sony, and the handheld PlayStation called PlayStation Vita from Sony. And they also have two newsletters. One is for Xbox One new releases and one for PlayStation 4 new releases. Signing up for these newsletters is optional. It's not tied to any purchase. Member can sign up for either one of these or both of these or none of these at will. It doesn't matter. So these are some of their sales records. They currently keep track of customer name, the item purchased, the shipping address, what newsletter this person signed up for, what is the supplier of the item, and what is the phone number of the supplier, and what is the price of the purchase. So they have someone named Alan Smith. These are just imaginary items. But anyway, there's somebody named Alan Smith. He bought an Xbox One. He lives in Miami. He subscribed for the Xbox newsletter. The supplier for the Xbox is Microsoft, and their phone number is 1-800-BUY-XBOX, and the price was $250. The next person named Roger Smith. Roger Banks. He bought a PlayStation 4. He lives on Campus Road in Boston. He subscribed for the PlayStation News, and that was supplied by Sony. Their phone number is by Sony, and the price of that was $300. The next person, Evan Wilson, he bought an Xbox One and a PlayStation Vita. He lives in Denver. He subscribed to both newsletters, and the supplier, it says wholesale, and the supplier phone number, it says toll free. This is what somebody entered in here, and the total price was $450. And there's another item named Alan Smith. It's the same as this, at least the name is the same. This person bought a PlayStation 4. He also lives on Campus Road in Boston, which is the same address as for this person, Roger Banks. He subscribed for the PlayStation News, Sony, by Sony, and the price was $300. And the color code, just ignore the color code. There's no meaning to that. It's just for visual cue. So anyway, these are some of their sales records, and I'm going to normalize these. So first normal form, the criteria are each cell to be single valued. So Xbox One and PlayStation Vita occur in the same cell, so is this. So we have to eliminate that. Entries in the column are the same type. So this one says wholesale and toll free here. These are not the same. These are not the proper values. So we need some kind of entry here that matches these. It would be like if, let's say, this field would be eye color, and someone put like I don't know, blue or green and beautiful. Well, beautiful is not a color; it's an opinion. So we need some kind of actual entry. We can't let this be in here. Also, rows uniquely identified. Either add a unique ID or add more columns to make the rows unique. Well, these rows, there's no duplicates in these rows, so they unique in a way, but there's still a question about this Alan Smith. Well, this Campus Road in Boston happens to be a housing for a college. So this Roger Banks rents a house while he's in college, and Alan Smith also rents the same house with them. They rent it together. So they have the same address while they are in college. So the question is now, is this Alan Smith from Miami is going to college in Boston, and this is the same guy? Is just now this is his address, or they are completely different people? From this table, we cannot figure that out. So those are the issues. So this is the table in first normal form. So each cell to be single valued. So the Evan Wilson, these two items, was separated out to two separate rows, one for Xbox One and one for PlayStation Vita. Notice this has 4 rows here, and this has now 5 because he made 2 purchases in one transaction. So that takes care of that. Entry and the column are the same type, while wholesale and toll-free was replaced with the proper values. So now we don't allow entry of just random values in here. They have to be filled out properly. And the rows must be uniquely identified. So these people are made to create some kind of customer ID that they can sign in to this website. So this person, his name happens to be Alan Thomas Smith, so he created a user ID AT Smith. Rogers Bank has Roger 25, Evan Wilson is Wilson 44, and this person, his name happens to be Alan Michael Smith, so his user ID is AM Smith. So now we know for sure that these two people have nothing to do with each other, and now we can uniquely identify each of these customers. Okay, second normal form. All attributes, meaning non-key columns, meaning these white ones, dependent on the key, which is this one, this red. So which one of these don't depend on the key? Well, let's see. How about the price? So does the customer ID determine the price? In other words, does the price depend on who buys it? And the answer is no. Doesn't matter who buys an Xbox One, the price will be the same. When Alan Smith or Evan Wilson buy it, the price will be the same. So the key in the table doesn't determine this. So we have attributes, meaning columns, that don't depend on the key. So those have to be separated out. So what I did is I take the customer ID, the name, the shipping address, and the subscription into one table, and then I take the item, which becomes the primary key, in the other table, the supplier phone number, and the price into another table. And obviously I'm only going to list one item one time. So now the price, the supplier, and the supplier phone and the supplier depend on this, because Xbox One has Microsoft to supply. This is their phone number and this is the price, and this customer has, this is his name, this is shipping address, and this is what is subscribed to. Obviously this person subscribes to 2, so he's in here twice. So this is great. The only problem is we lost the transactions. We don't know who bought what. So for that, there needs to be a table called the Junction Table, which is this. And basically these, in this table, both of these are a key. This is called a compound key because it's made up of 2 columns. And now these entries from AT Smith bought an Xbox One is over here. So this guy bought this, and Roger 25 bought a PlayStation 4, Wilson 44 bought an Xbox One and the Vita, and AM Smith bought a PlayStation 4. So the transactions are here, and now this and this are lookup table. So basically AM Smith bought an Xbox One. Who's AT Smith. Who is that guy? Well, his name is this, he lives here, and he subscribed to this. What's Xbox One? Well, Xbox One is supplied by Microsoft. This is how you buy more of it if you run out, and this is the price. So this is now in second normal form because every attribute depends on the key. We separated them out. Great. Third normal form. All fields, meaning columns, can be determined only by the key in the table and no other column. Okay, so what can be the problem here? Well, the problem is that Microsoft and the buy Xbox phone number always goes together. The Sony and the buy Sony phone number always goes together. It even says in here, this phone number is never gonna go with Microsoft, and this phone number is never gonna go with Sony. So in the item table, if the only thing we would know is Microsoft, we already know that this is the phone number, or if we know Sony, well, we know it's gonna be this the phone number. So obviously we need to separate it out also because these phone numbers keep repeating. If I would add more items here, like a camera for PlayStation, a camera for Xbox, controller, blah blah blah, you would notice that Microsoft Sony, and their phone numbers keep repeating. So if I would have to change the phone number, I would have to change it in a lot of different places, and it's not normalized properly. How about here? Can I figure out, let's say, the address from the customer name? Well, Alan Smith is one customer name. There's an address from Miami. Let's see. Oh, there's another address from Boston. So I guess there is no one-to-one relationship. How about backwards? Let's see. Campus Road goes with Roger Banks and goes with so I guess there isn't a one-to-one relationship between the name and the shipping address. Newsletter, well, that's definitely not going to happen because a person can sign up to multiple newsletters and multiple people can sign up to the same newsletter. So there's not going to be the same relationship as here. We can't just separate it out just yet. So what I did is basically separate this out. This for now is going to remain unchanged, but this is separated out. So I would remove the phone number column in here. So now the item is supplied by Microsoft and it's 250, but the phone number is listed here. So now if I need to change the phone number for either one of these, I can do it in one place, and there's no redundancy. And obviously the supplier is now its own primary key in its own table and is a foreign key in the item table. And the foreign key simply means that in here you can only enter values that appear here. If it's not in here, not in this table, you cannot put it in here. Let's say if you want to put in supplier Revlon or L'Oreal or something like that, those supply cosmetic products or whatnot. So if you don't sell those, you can't just enter in here. It has to be in the supplier table first before you can put it in here. That's what the foreign key means. Okay, so now all columns can be determined only by the key in the table and no other column. Well, this side is done for sure. There's no further way to normalize it. There's only this side left. So fourth norm or form, no multivalued dependencies. Well, what does that mean? What's a multivalued dependency? It's basically this. This field depends on the customer ID. This address depends on the customer ID. And the subscription depends on the customer ID. So these are all dependencies of the key. However, there's still a problem. As you can see, Evan Wilson is in here twice with the same address because he subscribed to 2 different newsletters. So if he would change his address, I would have to change it 2 places. Or what if he would unsubscribe to this thing? Then what do I just put a null here or try to dekludge my database because now I have 2 entries? Or what if it unsubscribe for both of them? Then I'm gonna have 2 nulls and 2 of the same values. Or same thing, if this person signs up for the Xbox newsletter, I repeat his user ID and the customer name and shipping address just basically like you either leave it as null or just randomly repeat it, because what are you gonna put there? So the multi-value dependency is a situation where one column can have different values, a different amount of values than, let's say, the other column. For example, in this database, I didn't allow multiple shipping addresses per customer. Every customer has one shipping address, but they have multiple newsletters. But in real life, let's say if you have an Amazon account, you can have multiple, let's say, credit card numbers on file, and at checkout you choose which one you want to use, and you could have multiple shipping addresses, one for home, one for work. So for one person, you could have, let's say, 2 shipping addresses and 4 credit cards. Well, how do you make a proper table out of that? The amount of rows in this column is not the same as in this column. Let's say, for example, I would have 1 shipping address and 2 credit cards, and then I would add another shipping address. What would I put in the credit card field? Just randomly select one of them. You see how that's a situation where you have these fields depend all on the key, which is called the multivalued dependency, but there's different amount of values that can be put into each row. In each column. So obviously at this point this needs to be separated out, and what I separated out is the customer ID, customer name, and the shipping address is gonna be one table, and the newsletter and the customer ID will be another table. These remain the same. So as you can see, now every customer only appears once. Wilson 44 was eliminated twice because we don't need that. So now if I need to change his address, he's only in here once. I don't have to change it twice, and these are his subscription. He's in here twice. So if the query that returns the what kind of newsletters need to go out will return him properly because he'll be in here twice. If this person signs up to another one, he'll be in here twice, and the query will return it accordingly. Or let's say Roger unsubscribes, he'll be removed, and the query that returns the newsletters will not return his name, but his address will be still intact here, no problem. These are the relationships between the tables, and also gave the tables names because now I know what they are. So this means this one too many. This means the customer appears in this table one time, but in the sales invoice table he will appear multiple times. An item will appear one time in the items table, but will be sold multiple times. Supplier will appear one time, but can supply multiple items. And the customer will appear one time here, but the person can have multiple subscriptions, or not at all, none at all. So now this table is fully normalized. And thanks for watching.